Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the confidence interval for the difference of two population proportions. And when you talk about the difference, you are talking about the subtraction process. So here we have proportion for the first population here, P1, minus the second population proportion here, so P1 minus P2. And we are going to apply this formula here, provided that data comes from large and independent populations. So these symbols which you are seeing right now are something which you have already seen in the previous video, except that we have it extended to more than one population here. So let me just explain a little bit about this formula given here. Well, if you're interested to find P1 minus P2, okay, therefore this part here has to be following the same convention, which is P1 hat, okay, the sample proportion for group 1 minus the sample proportion for group 2. Right, now if you are interested to switch the position, let's say you are interested to find the difference between P2 minus P1, so you have to change this bit here accordingly. So this will be changed to P hat 2 minus P hat 1. So it has to follow the convention saying over here. Okay, similarly for this one, also it has to be changed to P hat 2 minus P hat 1. Right, recall what is P hat. So P hat is x over n, so x is the number of successes, the number of subjects that has the attributes that you're looking for. And if you're talking about P hat 1, this is just the number of successes in that group 1 over the sample size in that particular group. And similarly, if you have P hat 2, this is just x2 over n2. And Q hat, so Q hat 1 is just 1 minus P hat 1. And similarly, Q hat 2 is just 1 minus P hat 2. Okay, this one here is the Z quantile, which will be obtained from the standard normal distribution table. And the formula given here can be written in a compact form, and it will look like this. Minus P hat 2, so plus minus Z alpha over 2. And here we will have P hat 1, Q hat 1 over N1 plus P hat 2, Q hat 2 over N2. So this is the formula written in a compact form. Alright, now let's look at the example given here. A researcher wanted to estimate the difference between the percentage of users of toothpastes who will never switch to another toothpaste. So this is the event of interest, and so this is the event of interest. Therefore, success is can be defined as the event where the user will not switch to another toothpaste. Yeah. In a sample of 500 users of Minty White taken by this researcher, 100 said that they will never switch to another toothpaste. So this one is the number of successes, which is X. Alright, so I'm just going to write down the information given here. So far we have the sample size for Minty White, which is equal to 500. And we get the result here, which is X. X for Minty White is equal to 100, and therefore the sample proportion for Minty White is going to be 100 minus over 500, and this is equal to, well, 0.2. So this is equal to 0.2. So if we have p hat equals to 0.2, therefore q hat for min ty is going to be equal to 0.8. So 1 minus 0.2 is 0.8. Alright, I think we need all the information regarding the first group. Now let's move on to the next group. Okay, so here another sample of 400 users of fresh breath taken by the same researcher. 68 said that they will never switch to another toothpaste. So this one is the number of successes in a second group. Okay, in the second group. So let's write down the information given here. So we have the sample size for fresh breath is 400. The value of x for fresh breath is 68. So therefore the sample proportion for fresh breath is going to be 68 over 400, which is equal to 68 over 400 is equal to 0.17. And since we know the sample proportion p hat, we can determine the value of q hat for fresh breath, which is 1 minus 0.7, and this is equal to 0.83. So these are the informations listed down here, and in particular the question is asking you to find the 97% confidence interval for the difference between proportions of all users. So let's say the difference between proportions is P population proportion for min ty minus the population proportion for fresh breath. So let's say this is what we are looking for. This is what we wanted to find the interval estimation for this one. And since the confidence level is 97%, we know that alpha is going to be equal to 3%, which is 0.03. Okay, so just for better understanding, maybe I should sketch the graph. So this is the standard normal distribution, and this is at point negative z alpha over 2. This is at point z alpha over 2, and this area here is going to be equal to 0.97, and therefore alpha is going to be on this end of this two distribution here. So on this side is alpha over 2, so alpha is 0.03, so alpha over 2 is going to be 0.015. So on this side the area here is also equals to 0.015. Okay, so next we are just going to consider the formula for the confidence interval here, and it is going to be p hat. So we are going to follow the convention given here, which is min ty and fresh breath. So min ty minus the sample proportion for fresh breath, so plus minus we have the z quantile from the standard normal distribution, and it will be multiplied with sample proportion for min ty, the q hat for min ty over the sample size for min ty. Next we're going to plus with the sample proportion for fresh breath and the q hat for fresh breath over its sample size. Okay, so next we're just going to plug in the values. So this one here is 0.2, so 0.2 minus 0.17. Okay, now plus minus. Now we need to find what is the value of z alpha over 2 here. So to find this value, you can refer to the standard normal distribution table, And in particular, I refer to table 3b because I think that's easier to be referred to. And in order to refer to that table, I need to know what's the area from this point here, z alpha over 2, to the end of this distribution, and I know that the area is 0.015. So I have to go and find where is 0.015 inside the table. You will see that for this, once you have found this value inside the table, the value of z is going to be equal to 2.17. Okay, so I trust that you will be able to find this value here. All right, next is we're just going to plug in other values here, which is 0.2 times 0.8 over 500. This one is 0.17 times 0.83 over 400. Now, when you plug in the values into your calculator, you will be able to get that this is simplified to 0.03 plus minus 0.0563. So therefore, the interval estimation for the difference between these proportions can be written as, so therefore, the difference in proportions, minty white minus fresh breath, is between these two values, where the lower limit is 0.03 minus 0.0563, and you will get that the answer here is negative 0.026, and the upper limit is going to be 0.03 plus 0.0563, so the answer is 0.086. so this is the 97% confidence interval for the difference between the two proportions here. Alright, I think that's all for now. Thank you very much for watching.